For our COBT viewers and listeners, it's Maynard, Mike, and Brett here with something, a special edition, if you will, something we thought you'd really enjoy, because we really enjoyed it. Last Monday, up in Austin, Texas, Brett and I attended an open house for Aalo Atomics. Today, we're going to visit with Matt Loszak. He's the CEO of Aalo Atomics. I think why this strikes us as interesting is obviously we're intrigued by nuclear, super nuclear supporters here at Veriton. But there's a lot going on in the nuclear space right now. It's gone from a space 3 or 4 years ago that wasn't getting much attention and had been kind of written off to a space that is now buzzing with all kinds of activity, lots of different approaches. It's going on globally. And for people like us who are, nuclear-ophiles, you want to try to keep up with it, but particularly want to keep up with the cutting edge, really interesting situations. And Matt has one. So Matt, on behalf of all of us, first of all, thanks for inviting us. It was really an impressive display. And then, secondly, of course, thanks for joining us to talk about Aalo and what's going on right now.
Of course. Yeah, I'm glad you guys could come, and thanks so much for having me on the pod.
Well, it was striking. I mean, I think the first thing you just notice is that there's not only optimism and excitement around nuclear, but to a large extent, nuclear is cool. Right, like your session on Monday, it's youthful, it's techy, it's energizing. You're right there in Austin, Texas, one of the capitals of technology. So the cultural element around it is very interesting. But I think you and Yasser, you should talk to it. But it felt like you and Yasser really try to focus people on the details and the reality of what you're doing, not just the sizzle and the excitement. But let me just ask you to comment on how you saw Monday, what the point of it was, and if you're pleased with how it came out.
Yeah, I think it was a great celebration of the progress so far. It's definitely still early days. Obviously, we have a lot left to do to prove here to achieve the mission. But yeah, it was a great celebration of having done a lot in a pretty short period of time. So I think a lot of people probably haven't heard of us because we're really only 2 years old as a company. And we essentially, a year ago, we were 5 or 10 people. Now we're 45. And in the next year, we plan to scale up to around 85 or 90. And we think that'll be the team size required to achieve criticality on that first plant that we're working on. But taking a step back, really what Monday was all about was unveiling a couple of the things we've been working on and really in the past 6 to 12 months. So 6 months ago, we moved into kind of an empty shell here in Austin. It's a 40,000 square foot kind of warehouse space. And in these 6 months, we built out a factory pilot line for not just the reactor, but really entire plants. And we finished a full-scale reactor prototype, which in the very near future, we've procured a plot of land here in Texas, 30 minutes east of our Austin HQ. And we're going to ship that prototype to that plot of land and do a lot of sodium testing. And I think there's a lot of interesting stuff there as well, because as I'm sure Brett can attest to, sodium reactors have a lot of potential, but then they also have challenges. So, aiming to rapidly de-risk those is another key thing. And the third thing we announced on Monday was the Aalo Pod, which is, we couldn't show it yet because it's our product. It's the plant that is purpose built for powering data centers. And what we wanted to highlight there is all the customer research and customer development that we've done on that product. And we've really tried to, on that product, kind of bridge, bottoms up cost physics from the nuclear side with kind of top-down customer discovery and building a product from scratch that customers actually want, instead of starting with some technology and then hoping to find some customer who wants exactly that configuration. So those are the three things that we were highlighting on Monday.
I was thinking we've been talking around here, Matt, of late, and the world has been really embracing this theme that we've really hit a pragmatic energy world after spending a number of years maybe not being as pragmatic as we should be. I notice in the way you guys talk about what you're trying to do is a few things. One, you talk about 3 cents a kilowatt hour being your objective. So you're not just saying we hope to produce clean power and the world will pay. You're saying we hope to produce cheap power, and that's just an orientation I think is worth highlighting. And then I think the other thing that was striking is you talked about how you see your niche, and I will mess this up, but a lot of people, we got micronuclear, we have SMRs, we have, quote, the big ones. You sort of talked about being a tweener size, if you will. And so I wondered if you might talk a little bit about your cost objectives and kind of how you see your product fitting into the market.
There's a few things that I'll touch on there: the pragmatism, the cost focus, and the product focus. So in terms of the cost focus, the ultimate mission of the company is to achieve below 3 cents per kilowatt hour electricity. But we're not deluding ourselves into thinking that's possible with a first-of-a-kind product. So really the challenge, and this comes back to the pragmatism, is how do you find a pathway from point A to point B to get to that eventual cost, while kind of crossing the chasm, the kind of valley of death, of going from folk to noke, like for the first-of-a-kind plant to the nth-of-a-kind, and bootstrapping the factory in the process. Because the factory is a key part of this. We see it as being a key part of the solution to what nuclear has been missing. Because if you kind of look at why we're not deploying more nuclear, it's not really primarily the regulatory blocker. It's more that utilities are afraid of cost and schedule overruns given the challenges we've seen in the West. So the approach that we're taking to cross that chasm is a few things. Primarily we're focusing on speed, because speed solves a lot of challenges. And if you can go faster, you can be more efficient with your capital. And frankly, the world just needs this stuff as soon as possible, because it's really, nuclear. I'm definitely biased, but I think nuclear is pretty incredible. Clean, baseload, super energy dense, and so on. But the way that we see ourselves in our product is, it's not a microreactor, because microreactors are usually 1 to 5 megawatt reactors and plant configurations, and their LCOE is usually 20 or 40 cents a kilowatt hour, and that's expensive, but that's okay because their target market is remote diesel. But our target market is AI data centers, and we don't think it will ever make sense to power a gigawatt data center with 1,000 1 megawatt reactors. And then you have SMRs, which are we're kind of designed around a utility model, and we're kind of the larger vendors taking a scaled down version of the existing plants. And we think the challenge there is that while parts of that might be modular, like the reactor, the entire thing doesn't end up being modular, and you end up with certain situations where you have for example, more concrete per megawatt than any other reactor design, because the design wasn't really rethought from the ground up. So what we presented on Monday was something that to some folks in the industry might seem like a small tweak, and to others might seem like a major new initiative, which we were kind of calling an XMR, like an extra-modular reactor, where the entire plant is modular and, importantly, vertically integrated and made in the factory, and then shipped on site for rapid assembly. So this XMR vision, our Aalo Pod, what's special about it is it has 5 reactors per 1 turbine. And this was coming back to what I said earlier around customer discovery, and talk to these folks. If you kind of do the economic modeling on this, even if you have to spend a bit extra and do like an N+1 configuration with an extra reactor, the value to the customer is that much higher, where it can also, essentially you have very high availability. So if any one reactor is down for refueling or maintenance, the others can make up the delta. And you can play with what the quoted nameplate capacity on the plant is as well to optimize this. But there's a lot of value to these customers in that high availability. And if someone were to ask you, hey, if you have a gigawatt data center, why don't you just build a gigawatt plant? And you might think, yeah, maybe just build a single gigawatt plant. But the challenge there is every 2 years it has to go down for a month for refueling, and data centers therefore would need a full grid backup. So even though capacity factor is, definitely a challenge for first of kind technology, the redundancy should be enough to help compensate for that to some extent. And certainly at some point, maybe, at nth of a kind, and whether n is 10 or 100, we'll see. But you should be able to, if you'd like, do a fully islanded configuration, which is very interesting because it saves time and money, time on interconnection queues, as we know they're very long right now, and money on decreased T&D due to the on-site nature of the power. So, yeah.
I was thinking about, particularly as you talk about the AI community and those customers, and then you think about, and this is simplistic, so bear with me here, Matt, but I think those of us on the outside who are watching all this, who are excited about it, have this like, okay, we know we need a SpaceX-like break down all the ways we used to do and think about nuclear and find a way to make it cheaper. And then the second thing I think a lot of us think is, well, the tech companies have great margins, great big balance sheets, and they're the customers that are really demanding this clean power right now. And so they'll be the ones to help finance it, right? And so can you talk about your team? You do have the SpaceX mentality. I talked to some of your team, some of them actually came from SpaceX, but talk about the mentality you need to make it work. And then we're lucky Jon Guidroz just joined us. John's an old friend from Microsoft, and he's now the commercial and strategy officer, senior vice president at the company. So, Jon, you've just joined us for a meaty question here, I think, which is, we got to break down this tech. How's the team going to do that and deliver it? And then the tech industry, how do you finance this? You got some customers that are ready, but you also have investors out there who are excited about this too. So let's talk about maybe both sides of the equation there, if you don't mind. And Matt, I'll start with you on the tech side. Like, how do you break all this down and make it affordable?
Yeah, so I think the first thing is we find ourselves right now in an environment like never before. And I think it really feels like this Goldilocks moment where there's all these factors like public support being at an all-time high, government support being all-time high, investor support being all-time high, customers. And what that all means is that you can start to attract some of the best talent in the world, because that talent wants to execute, right? In another kind of a different time, a lot of that talent, wouldn't want to kind of work on something where they're going to have to spend a decade without results, kind of thing. And we're very lucky that the nuclear industry, was able to survive through these kind of slower periods. But right now, we've been able to attract a lot of people who have just come from working on, like you said, SpaceX, Tesla. And then also, I think it's worth highlighting, we've hired a lot of people from oil and gas as well. And there's a lot of innovation in oil and gas from the past 20 years in Texas around fracking, which is, and kind of the treatment of natural gas and the ability to deal with leaks specifically that'll be very relevant for what we're doing here with these sodium reactors. But I think, primarily this comes down to the way that the culture is set up, and the idea that all these people coming together, there's kind of different types of psychology in how people work on this type of challenge. And the psychology of urgency, the psychology of trying to push forward at all costs into late hours and achieve this mission that is just incredibly meaningful. I think that's kind of, part of what, has been missing, and we're trying to create here at Aalo, is this culture of urgency. And I think Jon will be able to speak to the second side on kind of the customer side of this. So, yeah.
The question of how the market comes together and customers, particularly the tech sector, adopt advanced nuclear is just one that I sort of fell in love with as an opportunity and a riddle about 2 years ago, because I was at a tech company that wanted to acquire this power in bulk and in dispatchable ways. And Of course, the preference is we'll buy from the grid. But in many cases, that's just not an option. And nuclear has been built for the grid previously and will continue to be built to incorporate into the grid. But we have constraints in being able to bring that to market. And so this sort of Gordian knot of load growth and transmission bottlenecks with AI really pushing gave me a chance to sort of look in the mirror and say, we are the demand curve from the tech side that can bring about an unlock in this new commercial model. So there is no shortage of demand if we can meet it the right way. And we're very obsessed with talking with customers in the market to see what shape it needs to be, how it plugs in. I think one of the most important things that we're seeing in the market that helps unlock the financing side that you alluded to, Maynard, is a multi-deployment agreement, which is a very important way not to get stuck on the first-of-a-kind island. We want to build many, we want to deploy many, and tech is the type of customer that can do that with us.
So you guys are talking about AI as your target market, and what I've heard from Matt so far today is the cost angle. And I think with these data centers, what we're hearing is speed. Speed to market is what we hear most of. So maybe kind of talk about that. It doesn't seem like these data centers really care about cost right now. It's just give me the product today or tomorrow. Maybe talk about where you are on that, on that front.
Yeah, so I think you're spot on, and that's a big part of what makes this initial customer so perfect to help cross that vote to note chasm. And we talked about this on Monday. Speaking of perfect timing, beyond the public acceptance, the government acceptance, and so on, having this customer is incredible, because I really believe that this is the main thing that enables the factory vision to be achieved, right? For two main reasons. There's a higher willingness to pay because they care about speed. And if you can deliver that speed, then they're willing to pay for that. And also, second is because of the level of demand. I mean, we're talking about building many, many gigawatts of new data center generation capacity. And I'm sure most people on the call know this, but I mean, that's several cities worth of electricity. So this is, quite a rare circumstance. And the whole reason the factory makes so much sense here along the lines of speed is it allows for parallelization, right? And so if you build a single gigawatt plant, you kind of have to go and, do a lot of things in sequence that if this was done by having a few smaller reactors made in parallel in different factories and assembled rapidly on site, this just clearly allows you to move much faster as long as you can get those factories set up and cross that chasm that we're talking about crossing, which this customer is so helpful for doing. So I think it's incredibly exciting. I think nuclear has a once in a generation opportunity right now to get this factory model set up, because the reality is the factory has never been done for nuclear properly. Basically, every plant in the past was very large and very bespoke, and maybe onesies, twosies, threesies. But what we really need is this factory model, because it will bring predictability to cost and timeline, and it'll bring speed as a nice benefit. So we're super passionate about getting this pulled off, because we think this opportunity hasn't really existed really ever for nuclear in quite this way.
It makes total sense to me. But, obviously we're oil and gas guys here, but we're more than that. But I compare it to the oil and gas industry. It's like they wanted to. Some of the issues that happen there is offshore projects. Long lead times, very expensive to get it out there, and obviously you have a cyclical environment, oil and gas prices. And what they've done now is they've gone in there and said, okay, we're just going to fabricate all these, these offshore projects. We're going to do that, and they've lowered the cost quite significantly. And some projects that were not profitable 5, 6, 8, 10 years ago are now very profitable. And so it makes total sense to me that the fabrication route you guys are going totally makes sense.
I think the other side of the speed, and thank you for that analog. I think the other side of the speed story is credibility to deliver, right? If I put myself back in the chair at Microsoft, it sounds great, guys, but I can't count on a gigawatt and you not deliver, because that fundamentally will shrink my business in an unacceptable way, right? So this 50 megawatt building block is a de-risk and speed kind of sweet spot, right? You print your first 50, If that goes well, I know you're in the pipe to deliver another 50 megs and so on. And the shorter you can cycle that, it starts to look more like unconventional well manufacturing approach, right?
Jon and Matt, thank you again so much for having us the other day. And, I love anytime I get to be lumped in with the as an oil and gas guy. So I appreciate that, Mike. But
Brett, it's a false label.
no,
Broadly.
I'm taking it. No. But I do always, have to put my nuclear hat on, even if I am, trying to be falsely labeled sometimes. And on this speed discussion, it's fascinating. It's awesome to see what y'all built and be able to, walk up to it, look at the factory. It was a fantastic event. Many others are also, claiming things about prototypes. NuScale had their electrically heated demonstration a decade ago, pretty much at this point. So can you guys talk to us a little bit about where you go from here? Because obviously, we didn't see any nuclear fuel at this prototype this week and everything. And we know that there's going to be some testing, and we also know that you guys are pursuing a DOE project through a DOE authorization versus an NRC authorization for sort of a demonstration. But that may also kind of limit your commercial sort of opportunities with that demonstration versus some of the other demonstrations that are going on right now. So, or being talked about, I should say. So can you kind of talk to us about where you go from here with the prototype and what that means for kind of the next steps and how you kind of accomplish the speed that you're aiming to kind of, inject into this process?
Yeah, absolutely. It's a great question. So, starting off with painting a picture of the momentum so far, and then getting into where that momentum will push us to. We're around 2 years old as a company. We did the 6 million seed in year one. And so with that, we brought on the core tech team, finished the conceptual design. In year two, we did the 30 million Series A. And with that, as you saw, in around 6 to 9 months, we finished the factory, finished the full-scale prototype, and did a lot of customer discovery. Thank you, Jon, to create the Aalo Pod. And this is now year three, and we're in the process of raising a Series B. And what that will do is that will pay for the first real reactor. And our internal goal, don't quote me, so to speak, is we're aiming to start construction on the first real plant at Idaho National Lab next year, roughly in 12 months. That's our internal aggressive target. And what's really interesting is this will be a plant, right? Not just a reactor. And even in the past week or two, we're seeing a pretty rapidly evolving situation, which is the DOE is very interested in trying to remain at the forefront of both nuclear and AI with these data centers co-located with nuclear plants. And there's a lot of talk about potentially using national labs or military sites to build out a lot of these co-located nuclear plants and data centers for AI. And what's interesting is, we are following this DOE authorization path for that first plant. And as you know, DOE authorization is kind of purpose built for non-civilian soil, such as these national labs or military sites. So there's something interesting there brewing. Fundamentally, Aalo X is an experimental reactor to prove that we can do this quickly, prove the economics, and so on. But there's something really interesting there, and maybe I'll leave it at that for today. But then I kind of jumped over something, which is what we're doing in the next 6 to 12 months as we prepare for that approval to build that real reactor. Something else that we really, really care deeply about is, if you study the history of these sodium reactors, there's quite a few groups of folks who thought that they'd be this holy grail of economics because it allows you to make things more compact, which is very nice for factory mass manufacturing. And it also helps from a safety systems perspective because the liquid metal is so thermally conductive that in shutdown scenarios, you don't need the backup power, and you can kind of simplify some of these safety systems. And so, the thing is, all those groups who thought it would be a holy grail, there ended up being some economic challenges, primarily around maintenance or leaks or so on. And these are not safety, concerns. They're not radioactive leaks. They're just simply the challenges of dealing with sodium, which is, very compatible with stainless steel, but can smoke or catch fire if it enters the air. So this is why I drew that parallel with natural gas and fracking earlier. In Texas, in the past 20 years, we saw an incredible movement in natural gas, right? Natural gas was not a major energy player in the year 2000, but Texas and the brilliant folks here pushed it, and now it's surpassed coal as an electricity generation in the US. And there's a lot of innovation there, as was pointed out earlier, right, around the modularity and the factory used to improve the deployment of natural gas. And there's also a lot of learnings on how to deal with leaks and this leaky substance. So between the learnings there and the learnings in the first wave of sodium reactors, we will be answering the question in the next 6 to 12 months on what have we realized around sodium reactors that maybe were challenges in the past. And happy to give more details. There's certain basic things and certain other things that will require more development. But in that plot of land that I alluded to earlier, where we are now shipping this prototype, digging a 30-foot hole, installing it, we're going to do a lot of sodium testing, non-nuclear, and answer that question fundamentally, which is a big de-risk, which is, what have we realized that, the past efforts in the 1900s did not, that could unlock this holy grail of economics. And what excites me is this is, from first principles physics, a very solvable challenge. This is not fusion where, there's a number of Nobel Prize winning discoveries that have to be made before it's really feasible. This is kind of more like landing a rocket, where it's a tough engineering challenge, but it's doable. And if we achieve it, it unlocks fantastic economics. So I'll end my rant there.
That's a great, we've hit on a number of really good themes, guys. I was thinking, Matt, on this question of the oil and gas industry, its expertise. I mean, to this point on, the Monday event, it's clear, metal, vessels, construction of vessels, doing things in modular ways, and then shipping them on site. Leak detection. This type of thing, redundancy. I mean, there is a lot that is to Mike's theme. There's a lot that's recognizable for those of us who've hung around oil field service companies and just oil and gas companies in general. Could you imagine, this is a totally unfair question, but I think it's kind of the sign of the times. If an oil and gas company said, hey, I am not a nuclear expert, but I am pretty familiar with a lot of what you're doing. Can I partner with you? Can I jump in? Can we do some things together? I ask sort of practically, but I also ask because I think, a number of years ago, startup clean energy focused companies were kind of saying, no, I'd just soon not do that for various reasons. What's that? So it's a little bit practical and a little bit cultural. What is your reaction to that?
Yeah, I mean, we love this idea, and we want to work with oil and gas in so many different ways. So first of all, I think it's worth highlighting oil and gas is incredible, right? It brought us to where we are today. It brought so much wealth and high quality of life to humanity. So we have to acknowledge that. And so there's a number of ways we want to partner with the industry. So one is obviously hiring. There's a lot of jobs that are one-to-one between oil and gas and nuclear. And the same cannot be said, for example, of renewables, where a lot of the jobs are in China producing those panels. And so, that's one big area. And another one is essentially around, if you think about in the long term where this is going, oil and gas will last us maybe, another couple hundred years, and nuclear can last us 4 billion years. And so we do think that transition really makes sense, as soon as it makes sense to do so. And this AI customer is a fantastic catalyst to have that transition happen in the short term. I had a third point, and it's just escaping me. So, Jon, if you want to chime in here, and then I'll try to think of it so I can come back to it.
I'll just double down a little bit on this. I went from a utility scale renewable energy company to oil and gas, oil field services, and worked at a publicly traded OFS company for 7 years, and then went into tech. And now I'm here. And so to me, it's just a path of working in energy, period. And how do you bring together technology and execution around energy? So I've never really had a wall across those things. I think everyone's in the business of how do we get the best form of energy for humanity. And we did contract with oil and gas supply chain folks to achieve what you saw on Monday. We will continue to do so. We've got some paper in place for strategic collaborations with some folks in the oil and gas supply chain that you'll be hearing more about in the coming months. So I see no separation there. And I think it's a trend that will continue.
The thing I was going to say, sorry, that's completely just escaped my mind. But the other way that we really love to work with oil and gas is, so our business model, primarily in the longer term, will be to focus on the manufacturing on these reactors and plants and work with a network of partner developers to deploy a lot of this technology around the country and the world. And, similar to how Microsoft, makes $1 for every $4 their partners make, we want to work with a network of partner developers who will help deploy this technology around the country and different geographies and one day the world. So, for anyone who's deploying oil and gas infrastructure today, again, there's a very, interesting one-to-one bridge here. This is also a thermal generator. You need a turbine. There's a lot of parallels. So there's just so many ways we can work together as industries, whether it's that form of deployment or hiring the talent and so on.
Let me ask you one question, sort of cultural, that we kick around here as we see startup companies that are trying to develop a new technology, which is a physical technology, like a device of some kind, right? And it's going to be multi-year in however it plays out. There's this cultural question of, okay, it's going to be hard. You got to develop some new technology. You got to figure out a lot of stuff. But there's this weird, like, if it happened today or if it happened tomorrow, could we do it next week? Do we really need to work the weekend? Like, if something is going to take years, how do you, as leadership, you touched on this, Matt, but it's the right question. I don't think people understand, like, how do you create this intensity of, like, guys, I know it's going to take years, but we got to get the following done today. And then we're coming back tomorrow, and everybody's just got to grind like that, but you won't see the result. Like, there's a cultural question. I think, we read the Musk book and the demon mode and all these kinds of things. And I don't mean to be glib about how it's done, but there is some secret sauce for transformational development. How do you keep that intensity to make it happen?
I think there's two things that come to mind, and I was kind of hinting at this earlier, but in my career, I came from the software world where things move pretty fast, and something that I noticed is there's fundamentally a few different types of people, and some people, they just love going above and beyond and being around people who are just cranking out insanely great work. And there's some people that just don't necessarily want to do that, and that's fine, right? But you don't have to hire those people if you don't want to. And so if you create a company where everyone feels this immense passion for what they're doing and this immense urgency, then you can easily kind of set up all sorts of different milestones along the way and kind of push for those milestones. And there's a funny thing that happens in companies like SpaceX and Tesla where, it's kind of this thing that goes unsaid. They set deadlines that they know are unachievable. Right. But then the thing is, when you intentionally set a deadline that is unachievable, and then you turn a blind eye to the fact that it's unachievable, you'll find creative ways to move faster than you otherwise would have. And put differently, if you give yourself a certain amount of time to do something, you'll fill that amount of time. So, much better to set an unachievable deadline and then say, oh, too bad we missed it, but hey, we achieved something in 6 months that otherwise would have taken a year or two, than to set the year or two goal and maybe even be slower than that. That's kind of some of the core approach that we take, but maybe Jon would add something else to that.
I think it is a marathon with a bunch of sprints inside it, and the team right now is deeply motivated by being empowered, is what I'm observing. And I think as long as we can keep that up, we'll continue to have the execution and innovation sort of sweet spot. We've made some choices recently around fuel, as an example, a pivot towards something that's commercially available. I think at other companies, there would have been sort of this demoralizing moment of, oh my gosh, we have to change our fuel cycle. That's a big deal for a nuclear reactor company. Instead, folks, after a couple minutes of sort of discussing it, said, hey, this is an opportunity. We can go faster now that we're pivoting to existing fuel supply. So I think there's a sense of optimism in the company that if you can maintain that and continue to have people feeling empowered to deliver something new, it'll be a lot of fun.
Let me, we're kind of coming up on time. Mike and Brett, give us all a 15-second observation on how you think about the space, like for the audience, just to kind of close out. Jump in, either one. Sorry to put you on the spot, guys, but hey, we do this to our guests all the time. I mean, as you think about this space, what are you watching, or what are you thinking about, or what? It's obviously, it's incredibly intriguing.
When I think about the space, I think about where we were 2 years ago. We would have never even heard of it, your company or our other company. It was just really the big powerhouses, the Westinghouses, and there's this eco structure beneath that now that just, young guys like yourselves that are basically saying, hey, let's take this ball and run with it. And so when I look at it, I say, it's going to be here sooner than we think. It's going to be cheaper than we think. And it's just because of guys like you, and it's just, thinking outside of the box. And so that, to me, it's really exciting to see.
Well, I think that, two words kind of jump out at me here in this conversation. And the first word is steel, because we saw real steel. We were around it and everything. But then also, I think the word that jumped out in some of the discussion was the word real. And Matt kind of used that term specifically a couple of times when he's talking about their next project, first real reactor. So it's sobering to hear folks that understand the challenges and are looking to lean in to the development of this actual technology and call a spade a spade and say what they're doing, but actually be doing things at the same time, right? Because as we alluded to, this is hard and it takes time. And so that means roll up your sleeves and start doing it.
I think that's great. Steel and real. And Mike, yours was exciting and outside the box. Guys, we love spending time with you. We're intrigued by what you're doing, and we're so excited about this space. Any last thoughts from you about how the broad energy community that's watching this, what could they do to help, or what could they do to be useful, or how would you advise them on understanding this space? Because it is a really fast-moving with a number of angles, and so there's a lot to take in here.
Well, I mean, first of all, shameless plug. We are fundraising right now, so it's going well. But if people are interested in chatting on that, please do reach out. Secondly, obviously, collaborating is obviously super important. We've talked a lot on this podcast about how the oil and gas industry and nuclear should really be friends and work together and collaborate. And ultimately, I think every human in both these industries wants the same thing, which is to help humanity, to better humanity in all sorts of different ways. And so, I've been inspired in looking at the past and how oil and gas has done that for all of us. And I'm super inspired, obviously, by the potential for nuclear to do that. And so I think, the best odds we have at actually achieving that is by working together, and really excited to do so.
I'd say the commercial unlock is inevitable, whether it's Aalo or another. I happen to be biased and think it's going to be Aalo, but the commercial unlock is inevitable. So the community should be thinking about 4 years out, 5 years out, how they're helping to execute that and get a piece of the market that's coming. And we're definitely open for partnership, as Matt alluded to.
I think you guys are touching on something that we've noticed, because Brett joined us a little over 3 years ago. We started talking about nuclear more broadly and with better thinking, more informed thinking, but also we started talking about this notion of oil and gas partnering with nuclear. And a few years ago, the problem with that is it meant, getting into parts of nuclear that oil and gas was less comfortable with because it did not look like what they do. But as this space and you guys press ahead, this is the kind of stuff that perhaps oil and gas starts to look at and say, why can't we do that? Why wouldn't we do bring skills, we do have capital, we do have workforce, our shareholders might embrace that. So really fantastic conversation, guys. A great day last week on Monday, and appreciate your friendship and look for more to come.
Awesome. Thank you so much for having us on.
Thanks, everybody.